Asteroids and comets play a vital role in unraveling the mysteries of our solar system's formation. These celestial objects, remnants from the early stages of the solar system's evolution, offer valuable insights into the processes that shaped our cosmic neighborhood. Asteroids, rocky and metallic fragments scattered throughout space, provide clues about the building blocks of planets and their geological history. On the other hand, comets, composed of ice, dust, and organic compounds, hold the secrets of the early solar system's volatile and organic composition. By studying asteroids and comets, scientists can piece together the intricate puzzle of how our solar system came into existence and gain a deeper understanding of the cosmic forces that shaped our home in the vast universe. The universe is an ever-expanding canvas of celestial wonders, and within this grand tapestry, asteroids and comets hold a crucial role in unraveling the captivating story of our solar system's formation. These enigmatic objects, remnants of the early stages of cosmic evolution, provide valuable insights into the processes that sculpted our cosmic neighborhood. Through the study of asteroids and comets, scientists have unearthed remarkable discoveries, shedding light on the cosmic forces that shaped our home in the vast expanse of space. Ancient messengers from the cosmos. Asteroids and comets are ancient messengers, preserving the fingerprints of the early solar system. Asteroids, composed of rock and metal, are remnants of planetesimals that failed to coalesce into planets. Their diverse compositions and intriguing shapes offer clues about the building blocks of our terrestrial and giant planets. Comets, on the other hand, are icy wanderers originating from the outer regions of the solar system. These icy bodies provide invaluable insights into the volatile and organic composition of the early solar system. Planetary architects. Asteroids played a vital role in the architectural design of our solar system. Their gravitational interactions and collisions played a significant role in the accretion and formation of planets. By studying their orbits and sizes, scientists can reconstruct the intricate dance that led to the creation of our planetary system. Asteroid families, clusters of asteroids with similar characteristics, provide a glimpse into the dynamics and history of our solar system, allowing scientists to trace back its formation. Time capsules of cosmic history. Comets, with their icy cores, act as cosmic time capsules, preserving ancient materials from the birth of our solar system. As comets journey towards the Sun, the heat causes the frozen volatiles to vaporize, creating stunning tails that illuminate the night sky. Analyzing the composition of comets through space missions and ground-based observations has unveiled a treasure trove of organic compounds, including amino acids, which are fundamental building blocks of life. These findings provide tantalizing hints about the potential origins of life on Earth and the possibility of life elsewhere in the universe. Impacts and cataclysms. Asteroids and comets are not merely passive witnesses to cosmic history, they have also left an indelible mark on our planet. Impact events, such as the one that led to the extinction of the dinosaurs, highlight the immense power of these celestial objects. By studying impact craters and the geological signatures they leave behind, scientists gain insights into the cataclysmic events that shaped our planet's history. Furthermore, understanding the dynamics of asteroid and comet impacts is crucial for developing strategies to protect our planet from potential future threats. Conclusion. Asteroids and comets hold an intrinsic significance in our quest to understand the formation and evolution of the solar system. Through their diverse compositions, orbital dynamics, and impact events, these celestial objects provide us with a glimpse into the cosmic processes that shaped our home. From unraveling the building blocks of planets to uncovering the origins of life, the study of asteroids and comets has sparked our imagination and expanded our understanding of the vast and intricate cosmos in which we reside. As we continue to explore and unlock the secrets of these ancient messengers, we move closer to painting a complete picture of our cosmic origins, unveiling the profound beauty and complexity of the universe that surrounds us. The history of asteroids and comets and their role in the formation of the solar system is a fascinating journey that spans billions of years. Let's explore their story from the early stages of the solar system to our current understanding. The birth of the solar system. Around 4.6 billion years ago, a vast molecular cloud known as the solar nebula began to collapse under the influence of gravity. As the cloud contracted, it formed a spinning disk of gas and dust, known as the protoplanetary disk. Within this disk, regions of higher density started to emerge, leading to the formation of planetesimals, small, solid bodies ranging from meters to kilometers in size. Planetesimal formation. The planetesimals formed through a process known as accretion, where the dust and gas in the protoplanetary disk clumped together due to mutual gravitational attraction. These early building blocks consisted of a mixture of rock, metal, ice, and organic compounds. Over time, collisions and gravitational interactions caused the planetesimals to grow in size, forming larger objects known as protoplanets. Asteroids, relics of the early solar system. Not all protoplanets managed to become fully fledged planets. Some experienced gravitational disturbances, leading to their fragmentation and the creation of a vast population of smaller rocky and metallic remnants. These remnants are what we now know as asteroids. They range in size from tiny fragments to dwarf planets like Ceres, which resides in the asteroid belt between Mars and Jupiter. Asteroids provide valuable insights into the early stages of planet formation, as they represent the building blocks that did not accrete into larger bodies. Comets, frozen wanderers from the outer reaches. Comets, on the other hand, have a different origin. They originate from the outer regions of the solar system, specifically the Kuiper belt and the Oort cloud. These regions are composed of icy bodies primarily composed of water ice, mixed with dust and other volatile compounds. Comets are thought to be remnants from the early solar system that remained in cold storage until gravitational interactions perturbed their orbits, causing them to venture closer to the Sun. Impacts and cataclysmic events. Throughout the history of the solar system, asteroids and comets have played a significant role in shaping the planets and their environments. Impact events have occurred with varying degrees of magnitude, leaving behind enormous craters on planetary surfaces. Notable examples include the Chicxulub impact that occurred around 66 million years ago, resulting in the extinction of the dinosaurs, and the Barringer crater, meteor crater, in Arizona, USA. These impacts have influenced geological processes, altered atmospheric conditions, and potentially even affected the development and evolution of life on Earth. Scientific exploration and discoveries. Humanity's fascination with asteroids and comets has led to numerous scientific endeavors to study and understand these objects better. Space missions, such as NASA's Dawn mission to the asteroid Vesta and the dwarf planet Ceres, and the European Space Agency's Rosetta mission to Comet 67P/Churyumov-Gerasimenko, have provided unprecedented insights into their composition, structure, and surface features. These missions have revolutionized our understanding of asteroids and comets, revealing their complex geology, volatile composition, and potential as repositories of pristine materials from the early solar system. In conclusion, the history of asteroids and comets is intertwined with the evolution of the solar system itself. From the formation of planetesimals to the cataclysmic impacts that have shaped our planets, these objects hold important clues about the processes that led to the birth of our cosmic neighborhood. Through ongoing scientific exploration and discoveries, we continue to unravel their secrets, deepening our understanding of the cosmos. Asteroids and comets form through different processes in the early stages of the solar system. Let's explore their formation mechanisms individually. Asteroid formation. Asteroids are primarily formed through a process called accretion. In the protoplanetary disk, as dust and gas particles collide and stick together due to mutual gravitational attraction, they gradually form larger objects called planetesimals. These planetesimals range in size from meters to kilometers and are the precursors to asteroids. Over time, through further collisions and gravitational interactions, some planetesimals grow in size, while others fragment or collide, creating a diverse population of asteroids. These rocky and metallic remnants represent the building blocks that did not form into planets. Comet formation. Comets have a slightly different formation process, primarily occurring in the outer regions of the solar system. The outer regions are populated by two main reservoirs of icy bodies, the Kuiper belt and the Oort cloud. The Kuiper belt, located beyond Neptune's orbit, contains icy objects composed mainly of water ice, mixed with dust and volatile compounds. The Oort cloud is a more distant and spherical region surrounding the Solar System, believed to harbor a vast number of icy bodies. Comets are thought to form as a result of gravitational perturbations caused by the presence of the giant planets, such as Jupiter and Saturn. These perturbations can alter the orbits of these icy bodies, causing them to move closer to the Sun. As comets approach the inner Solar System, the heat from the Sun causes the volatile ices to vaporize, creating a glowing coma, a cloud of gas and dust, around the nucleus, and often developing a spectacular tail that points away from the Sun due to the solar wind. The formation of comets likely involves the accumulation of icy particles in the outer regions of the Solar System during the early stages of its formation. These particles then gradually aggregate to form larger bodies, which become the nuclei of comets. It's important to note that the exact details of asteroid and comet formation are still subjects of ongoing research and investigation. Scientists use a combination of theoretical models, computer simulations, laboratory experiments, and data from space missions to gain a deeper understanding of these processes and refine our knowledge of how asteroids and comets form in the intricate dance of the evolving solar system. Asteroids and comets are found through various methods, including both ground-based observations and space-based missions. Let's explore some of the techniques used to detect and study these celestial objects. Ground-based observations. A. Telescopic surveys. Astronomers use ground-based telescopes equipped with advanced imaging and detection systems to survey large areas of the sky systematically. These surveys scan the night sky, capturing images and collecting data on celestial objects. By comparing multiple images taken at different times, astronomers can identify objects that have moved, indicating they are not fixed stars but potentially asteroids or comets. B. Photometric and spectroscopic analysis. Through photometric measurements, astronomers analyze the changing brightness of objects over time. Asteroids and comets can exhibit characteristic patterns in their light curves, allowing for identification. Spectroscopic analysis involves breaking down the light from these objects into its component wavelengths, revealing unique spectral signatures. These signatures provide information about the composition and surface properties of asteroids and comets. C. Astrometry. Astrometry involves precisely measuring the positions and motions of celestial objects. By tracking the positions of known asteroids and comets and comparing them with predicted positions, astronomers can identify new objects or determine the orbits of known ones more accurately. Space-based missions. A. Dedicated space telescopes. Space telescopes, such as the Hubble Space Telescope, HST, and the upcoming James Webb Space Telescope, JWST, provide a clearer and more detailed view of the cosmos by observing from outside Earth's atmosphere. These telescopes can study asteroids and comets, capturing high-resolution images, conducting spectroscopic analyses, and studying their physical properties. B. Mission-specific probes. Space agencies, including NASA and the European Space Agency, ESA, have launched missions specifically designed to study asteroids and comets up close. Examples include NASA's Dawn mission to the asteroids Vesta and Ceres and the ESA's Rosetta mission, which rendezvoused with comet 67P/Churyumov-Gerasimenko. These missions collect data through close flybys, orbit insertions, and even landing on the surfaces of these objects, providing detailed information about their composition, structure, and surface features. Citizen science initiatives. Citizen science projects, such as the Asteroid Zoo and the Comet Hunters, engage the public in the search for asteroids and comets. Participants can analyze telescope images and help identify moving objects that may be previously undiscovered asteroids or comets. By combining data from ground-based observations, space missions, and the contributions of citizen scientists, astronomers can continuously update catalogs of asteroids and comets, refine their orbits, and make new discoveries. These efforts contribute to our understanding of the population, properties, and dynamics of these fascinating celestial objects and their roles in the formation and evolution of the solar system. Asteroids and comets are composed of different components that provide valuable insights into the formation and evolution of the solar system. Let's explore the components of asteroids and comets and their significance in understanding these objects. Asteroids. A. Rock. Asteroids primarily consist of rocky materials, such as silicates and metals. These rocky components include minerals like olivine, pyroxene, and nickel-iron alloys. The composition of rocks within asteroids varies, reflecting different formation locations and processes. B. Metals. Some asteroids contain a significant amount of metallic elements, such as iron and nickel. These metallic components often make up the core of differentiated asteroids, formed through a process where the denser materials sink to the center during early planetary formation stages. C. Regolith. The surface of many asteroids is covered by a layer of loose, fragmented material called regolith. It consists of small rock and dust particles, often created through impacts and weathering processes. Studying regolith provides insights into the geological history, surface processes, and the interaction of asteroids with their environment. D. Volatiles. While most asteroids are primarily rocky, some may contain small amounts of volatile substances, such as water ice, carbon dioxide, and methane. The presence of volatiles indicates potential interactions with icy bodies or the delivery of volatile-rich materials during their formation. Comets. A. Ice. Comets are predominantly composed of ices, primarily water ice, mixed with other volatile compounds like carbon dioxide, methane, and ammonia. These ices are thought to have originated from the outer regions of the solar system, where temperatures are low enough for them to remain in solid form. B. Dust. Comets also contain a significant amount of dust particles mixed with the ices. These dust grains range in size from tiny micrometer-sized particles to larger pebbles. The composition of cometary dust provides valuable information about the early solar system's solid materials. C. Nucleus. The nucleus is the solid core of a comet and contains a concentration of icy and rocky materials. It is typically a few kilometers in size and serves as the source of the comet's activity when heated by the sunday. The nucleus may be irregularly shaped and can exhibit variations in composition across its surface. D. Coma and tail. As a comet approaches the Sun, the heat causes the icy nucleus to vaporize, creating a glowing coma, a cloud of gas and dust around the nucleus. The coma may extend for thousands of kilometers. Solar radiation and the solar wind push the coma's gas and dust particles away from the Sun, forming a characteristic tail that points in the opposite direction of the sunday. Studying the components of asteroids and comets provides valuable insights into the early solar system's composition, dynamics, and the processes that led to the formation of planets. The diverse mix of rocky materials, ices, and volatile compounds within these objects helps us understand the distribution of resources, the role of impacts in planetary evolution, and even the potential for habitable environments in other planetary systems. Asteroids and comets come in various types based on their composition, location, and characteristics. These different types provide valuable information about the formation and evolution of the solar system. Let's explore some of the main types of asteroids and comets. Types of asteroids. Carbonaceous, C-type, asteroids. Carbonaceous asteroids are rich in carbon and organic compounds. They are believed to be some of the most primitive objects in the solar system, containing materials that have remained relatively unchanged since the early stages of its formation. C-type asteroids are often found in the outer regions of the asteroid belt. Silicate, S-type, asteroids. Silicate asteroids are composed mainly of silicate minerals, such as olivine and pyroxene. They are generally brighter and denser than carbonaceous asteroids. S-type asteroids are found closer to the inner regions of the asteroid belt and are thought to originate from the inner parts of the protoplanetary disk. Metallic, M-type, asteroids. Metallic asteroids are primarily composed of metals, such as iron and nickel. They are thought to be the remnants of differentiated bodies where the heavier materials sank to the core during the early stages of planetary formation. M-type asteroids are often found in the inner regions of the asteroid belt. Trojan asteroids. Trojan asteroids are a unique group that shares the same orbit as a planet, either leading it or trailing behind it at stable Lagrange points. They are commonly found near the gas giant planets, such as Jupiter and Neptune. Trojan asteroids provide insights into the dynamics and stability of the solar system. Types of comets. Long-period comets. Long-period comets have highly eccentric orbits that bring them from the distant Oort cloud, a reservoir of icy bodies surrounding the solar system. These comets can take thousands to millions of years to complete one orbit around the Sunday. They have higher inclinations to the plane of the solar system and are often associated with more dramatic and extended tails. Short-period comets. Short-period comets have orbits that originate from the Kuiper belt, a region beyond Neptune's orbit. These comets typically have orbital periods of less than 200 years. Examples include the famous Halley's Comet, which returns to the inner solar system approximately every 76 years. Jupiter family comets. JFC's Jupiter family comets have orbital periods less than 20 years and are influenced by Jupiter's gravitational pull. Their orbits are generally more confined to the inner regions of the solar system. JFCs originate from the Kuiper belt and are believed to have been captured by Jupiter's gravity. Halley-type comets. Halley-type comets have orbits that are similar to that of Halley's Comet. They have orbital periods between 20 and 200 years and are a subgroup of the short-period comets. These comets originate from the Kuiper belt or the scattered disk beyond it. These various types of asteroids and comets provide clues about the conditions, processes, and locations where they formed in the early solar system. By studying their compositions, orbital characteristics, and behaviors, scientists gain insights into the diversity of materials and the complex dynamics that shaped our cosmic neighborhood. There are several well-known asteroids and comets that have played significant roles in our understanding of the solar system's formation and evolution. Here are a few popular examples. Asteroids. Ceres. Ceres is the largest object in the asteroid belt between Mars and Jupiter and was the first asteroid to be discovered. It is classified as a dwarf planet and is believed to have a differentiated interior with a rocky core and an icy mantle. The NASA Dawn mission studied Ceres in detail from 2015 to 2018, providing valuable insights into its composition and surface features. Vesta. Vesta is the second largest asteroid in the asteroid belt and is known for its unique surface composition. The NASA Dawn mission also visited Vesta before reaching Ceres, providing detailed images and data about its geological features and history. Vesta is believed to be a remnant protoplanet and has an exposed mantle of basaltic rock. Eros. Eros is a near-Earth asteroid and was the first asteroid to be orbited and landed upon by a spacecraft. The NASA Near Shoemaker mission studied Eros in 2000 and provided valuable data on its composition, structure, and surface properties. Comets. Halley's Comet. Halley's Comet is perhaps the most famous and well-observed comet. It has a periodic orbit and returns to the inner solar system roughly every 76 years. Halley's Comet has been observed and recorded by astronomers for centuries and provided insights into the nature of comets and their periodicity. Comet 67P/Churyumov-Gerasimenko. This comet gained significant attention due to the European Space Agency's Rosetta mission, which rendezvoused with the comet and deployed a lander called Philae onto its surface in 2014. The mission provided unprecedented data and images of the comet, offering insights into its composition, structure, and activity. Comet Hale-Bopp. Comet Hale-Bopp was a prominent comet visible to the naked eye in 1997. Its long period and highly eccentric orbit brought it from the distant Oort cloud. Hale-Bopp sparked public interest and excitement, leading to extensive observations and scientific investigations. These popular asteroids and comets have contributed greatly to our understanding of the solar system's formation, composition, and dynamics. Through missions and observations, they have provided valuable data and insights that have helped refine our models and theories about the early stages of our cosmic neighborhood. While my knowledge cutoff is in September 2021 and I don't have real-time access to the latest research, here are a few recent developments and ongoing research areas related to asteroids and comets. OSIRIS-REx mission, NASA's OSIRIS-REx, origins, spectral interpretation, resource identification, security, regolith explorer, mission reached its target, the asteroid Bennu, in December 2018. The mission aimed to collect a sample from the asteroid's surface and return it to Earth for detailed analysis. The sample return capsule successfully landed in September 2020, and scientists are now studying the collected material to gain insights into the early solar system's composition and the role of asteroids in its formation. Comet Interceptor mission, the European Space Agency, ESA, is planning the Comet Interceptor mission, scheduled for launch in the early 2030s. This mission aims to study a pristine comet that has never interacted closely with the Sun before, providing valuable information about the composition and characteristics of comets in their pristine state. Impact and collision studies. Researchers continue to study the impact and collision processes involving asteroids and comets. By simulating impact events and studying the resulting crater formations, scientists gain insights into the role of these objects in shaping planetary surfaces, delivering volatiles and organic compounds, and even triggering mass extinction events on Earth. Composition and volatile mapping. Ongoing research focuses on analyzing the composition of asteroids and comets to understand their origin and the distribution of volatile materials. Space missions, such as NASA's Lucy mission, targeting Trojan asteroids, and Psyche mission, targeting a metallic asteroid, aim to study the compositions and characteristics of these objects in more detail. Asteroid and comet surveys. Several ongoing ground-based surveys, such as the Pan-STARRS and the Large Synoptic Survey Telescope, LSST, are systematically searching the sky for asteroids and comets. These surveys help identify new objects, track their orbits, and provide data for population studies to better understand the demographics and properties of these objects. Formation and migration models. Researchers continue to refine models and simulations to understand the formation and migration of asteroids and comets. By incorporating new data and observations, these models help explain the distribution, compositions, and dynamics of these objects in the early solar system. These are just a few examples of the active research areas concerning asteroids and comets. Ongoing studies, observations, and missions are continuously expanding our knowledge and providing exciting discoveries that contribute to our understanding of the formation and evolution of the solar system. Here are some interesting facts about asteroids and comets and their role in the formation of the solar system. Building blocks of the solar system. Asteroids and comets are considered remnants from the early stages of the solar system's formation. Studying these objects provides insights into the composition and conditions present during that time. Composition variety. Asteroids and comets have diverse compositions. Asteroids are primarily rocky, while comets are predominantly made up of ices, such as water ice, mixed with dust particles. Asteroid belt. The asteroid belt is a region located between Mars and Jupiter, where most asteroids are found. It contains millions of asteroids, ranging in size from small boulders to the dwarf planet Ceres. Kuiper belt and Oort cloud. Beyond the orbit of Neptune, there are two regions known as the Kuiper belt and the Oort cloud. These regions contain a large number of comets, including both short-period and long-period comets. Impact craters. Both asteroids and comets have been involved in significant impact events throughout the solar system's history. Impact craters provide evidence of past collisions and their effects on planetary surfaces. Water delivery. Comets are believed to have played a crucial role in delivering water and volatile compounds to the inner planets, including Earth. The impact of comets on early Earth may have contributed to the development of suitable conditions for life. Trojans and Lagrange points. Trojans are asteroids that share the orbit of a planet, residing in stable regions known as Lagrange points. These points are where the gravitational forces of the Sun and the planet balance out, allowing asteroids to remain in stable positions. Near-Earth objects. Neos are asteroids and comets whose orbits bring them close to Earth's orbit. Studying Neos is important for understanding potential impact hazards and developing strategies for planetary defense. Space missions. Several space missions have been dedicated to studying asteroids and comets up close. These missions, such as NASA's OSIRIS-REx, Japan's Hayabusa 2, and the European Space Agency's Rosetta, have provided detailed data on the composition, structure, and dynamics of these objects. Origin of life. Asteroids and comets may have played a role in delivering organic compounds, including amino acids and other building blocks of life, to early Earth. The study of these objects contributes to our understanding of the origins of life in the solar system. While asteroids and comets play significant roles in the formation of the solar system, there are some limitations and challenges in our understanding of these objects. Here are some faults or areas of uncertainty. Sample representativeness. Our knowledge about asteroids and comets is primarily based on the analysis of a limited number of samples brought back to Earth by space missions. While these samples provide valuable insights, they might not be fully representative of the entire population of asteroids and comets. Generalizing findings to all objects in these categories can be challenging. Limited observation opportunities. Due to the vast distances and the nature of their orbits, opportunities for close-up observations and detailed studies of asteroids and comets are limited. Space missions to these objects are relatively rare and resource-intensive, which restricts the scope of our direct observations and measurements. Fragmentation and erosion. Asteroids and comets can undergo fragmentation and erosion due to various factors such as impacts, heating, and radiation. This process can alter their composition and surface features, making it challenging to determine their original characteristics and history accurately. Incomplete understanding of formation processes. While we have developed models and theories on the formation of asteroids and comets, our understanding of the specific processes and mechanisms involved is still evolving. Uncertainties remain about the exact mechanisms that led to their formation and the factors that influenced their composition and distribution. Dynamic nature. The behavior and activity of asteroids and comets can vary significantly depending on factors such as their proximity to the Sun and their composition. Predicting and understanding their behavior, such as outgassing and the formation of tails, can be complex and challenging. Reliability of impact models. Impact events involving asteroids and comets have played a significant role in shaping the solar system, including causing mass extinctions on Earth. While impact models provide insights into the consequences of these events, predicting specific outcomes and their long-term effects can be uncertain due to the complexity of the interactions involved. Limited knowledge of small objects. Most of our knowledge about asteroids and comets comes from studying objects of a certain size range. Smaller objects, including those that are harder to detect or study, might hold additional information that is currently unknown or underrepresented. Addressing these faults and expanding our understanding of asteroids and comets requires ongoing research, advancements in space exploration technology, and the analysis of new samples and observations. Despite these limitations, scientists continue to make significant progress in unraveling the mysteries surrounding these objects and their role in the formation and evolution of the solar system. Asteroids and comets have captivated scientists and astronomers for centuries, offering windows into the formation and evolution of our solar system. These objects, with their diverse compositions, orbital dynamics, and intriguing behaviors, hold valuable clues about the conditions that prevailed during the early stages of our cosmic neighborhood. From the asteroid belt to the Kuiper belt and beyond, these celestial wanderers have left their marks on planetary surfaces, delivered volatile compounds, and even influenced the development of life on Earth. While our understanding of asteroids and comets is still evolving, the ongoing research, space missions, and technological advancements continue to unveil the secrets hidden within these enigmatic bodies. Exploring the roles of asteroids and comets in the formation of the solar system is not only a journey into the past but also a pathway to unlocking the mysteries of our cosmic origins and the potential for life beyond our planet. As we gaze at the night sky, these cosmic nomads remind us of the dynamic and ever-changing nature of our universe, inspiring us to explore and seek answers to the profound questions that lie among the stars.